Okay, so welcome back. We're looking at the domain of these two graphs. Domain, if you recall, is our x values, all of the possible inputs for the function. And when we look at graph A, we can see our lowest possible value for x is a -4. Okay, if we go along this continuous path, we're headed up, up, up. And when the line extends to the edge of a graph, you can assume it keeps heading in that direction forever, right? So there's an implied arrow on the end of this graph. So x has an open circle, or our graph has an open circle where x is -4 on the left side, but it's continuous all the way up to positive infinity on the right side. So the x's can be anything strictly greater than -4. Right? We're going to have non-inclusive because of this open circle. Okay, now let's take a look at the range. Range is all the possible y values, right? We want to start at the lowest y value, and that's here at -1. Okay, so the graph begins at its low point, the vertex of this parabola, this U-shaped graph, where y is -1, and then it goes on the left side up to this open circle at 3, but on the right side it goes through the 3, past the 3, and again up forever. So even though it's open on the left, right, it is included in the range, this 3, because it's closed on the right side and then heads up to infinity. So our y's, the range, can be anything greater than or equal to that lower bound of -1. Okay, is this a function? Well, this parabola, this piece of a parabola, passes the vertical line test. So yes, it is. Each x is paired with one and only one y value. Okay, in our last example, let's go back over to that one. Example 2, we were looking at bounded intervals, right? The domain and range were bounded because the x and y values were continuous between two real number endpoints. Now in example 3, we have half-bounded intervals, right? The x only has values greater than -4, so we have one real number endpoint, but the other end is going up for forever, right, up to positive infinity in both the x and the y direction. So we call these intervals half-bounded. Okay, let's take a look at example B. So here we have a V-shaped graph that's called an absolute value graph, and we're going to look more at absolute values in later chapters as well. So the domain of this V-shaped graph, our lowest possible x value, is here at -2. So beginning at -2, we come across, it's continuous forever and ever, and we reach the edge of the graph, so we'll put an arrow there to show that it's going forever to the right and down. Now, domain is the x's. The x's aren't getting smaller. The x's are getting bigger, right? X is 0, 1, 2, 3, 4, 5, and so on. It's the y values that are headed downward. So since domain is x's, we're staying focused on the x's that are possible for this graph. The lowest possible x is -2. And there is no highest, right? X is going to keep on growing. So the x's must be greater than or equal to that -2, that lower bound. We use the equals because it's a closed circle. So this is inclusive at that endpoint. Okay, now let's look at the range. Range is y values, right? We want to start at the bottom, go up to the top. So our y values have no bottom, right? This end of the graph on the right is going down forever. So these y values go down to negative infinity. They go up to a highest value, though, at the vertex of this V-shaped graph, and that y value is here at 4. So y's can be anything up to and including positive 4. So the y's are greater than, are less than, the y's are less than or equal to positive 4. Okay, and this V-shaped graph passes the vertical line test, so yes, it is a function. Okay, since these intervals have one real number endpoint, the other end is going forever, either up or down, these are half-bounded intervals. Okay, next we're going to look at some unbounded intervals. So in example 4, right, we can see that both of these graphs have ends that go forever left and right, forever up and down, right? Same thing over here. This one is going down and to the left. This one is going up and to the right. So they're continuous between positive infinity and negative infinity in both the x and y direction, right? Continuous between positive and negative infinity, both x and y direction. So the domain is all real numbers, right? X can be anything at all. And the symbol for all real numbers is a capital R with a double line in front of it. Okay, the range is also unbounded, right? There's nothing to prevent us from going all the way from bottom to top on this graph. So the range is the set of all real numbers. Okay, this cubic graph, this wiggle shape, is going to pass the vertical line test, and so it is a function. Okay, looking at B, right, forever left and right, there's no restrictions from the domain. X can be any real number, so the set of all real numbers. This graph goes forever up and down, so the range is also the set of all real numbers. But we fail the vertical line test on this graph, so it is not a function, it is a relation only. Okay, so pause the video and go ahead and try these two problems on your own on some scratch paper or your whiteboard. And when you're ready to check your answers, go ahead and resume the video. Okay, so we're back, and the domain for A is x's that are strictly less than 2. Right, here's our upper bound of 2. It's an open circle, so we're not going to use an equals. Right, this is non-inclusive at that endpoint. It's a half-bounded interval because the x's go down to negative infinity, right? X can be 2, 1, 0, -1, -2, -3, -4, on down to negative infinity. So half-bounded for the domain. The range, our lowest possible y value is down here at -4. That's inclusive because there is no open circle shown there. And we use an equals with our inequality to show that it's an inclusive endpoint, right? That lower bound is closed at -4. Then our y values are continuous all the way up to positive infinity. So the y's can be any real number greater than or equal to -4. We don't worry about the open circle when we're thinking about the y values, the range, because it's closed at another location on the graph, so it is inclusive. And looking at example B, right, we have continuous line here all the way to the left and right, up and down, so the domain and range are both unbounded, right, the set of all real numbers. And this graph fails the vertical line test, so no, it is not a function, it is a relation only.